Hey guys, so today we're going to be going over a problem that involves a circuit. So we have a 7 ohm resistor that is connected across the terminals of a battery having an internal EMF of 10 volts. If 0.50 amperes of a current flows through the circuit, what is the internal resistance of the battery? So let us draw out what this circuit would look like. So we have the battery, right? So that's just going to be E, and that's 10 volts. And then we have another resistor. So that's going to be, let's say, R1 equals 7 ohms. Now, after that, there's nothing else. So that just connects back to the negative end of the battery. So they tell us that there is a current flowing through of 0.50 amperes, right? So there is also another thing we have to consider, which is that the battery itself has its own internal resistance. So let's give that R2. So I'll put a question mark to show that we're looking for the resistance of the battery, which is capital R2. So there's a generic formula that everyone should know when approaching a circuit, which is V equals IR, right? So now, since we know the question's asking for resistance, let's manipulate this equation to find the resistance. So R equals V divided by I. So here's the thing, right? In this equation, what is the resistance? Well, we have two. We have R2 and R1. When you are doing calculations for a series circuit and you're using all the values here, right? Well, first of all, because the current is constant throughout the whole loop, right? That means that we should use the equivalent resistance for the whole loop. Okay, so the equivalent resistance for a series circuit is going to be R1 plus R2, and this is because it is in series. Okay, so let's use this information that we just got. Okay, so once we combine that information and we combine it, let me see. Okay, let's say with the R equals VI equation, well, V over I, and the REQ equals R1 plus R2, let's try to figure this out, okay? So let's rewrite it as REQ equals E over I, okay? Because you're supposed to use the equivalent resistance when you're doing this kind of calculation. So REQ is equal to R1 plus R2, and this is still equal to E over I. So we just substituted the true values for REQ. Now that we're here, okay, let us do some more calculations. So we know that R1 is equal to 7, and we know that E is equal to 10, and I is equal to 0.5. So let's plug that in. So we're going to get 10 divided by 0.5 is equal to R2 plus 7, right? So far we have 7, which was the R1. We have the E over I, which is the 10 divided by 0.5. So let's do some more calculations. You're going to subtract 7 from both sides, and you're going to get, well, first of all, 10 divided by 0.5 is just 20. So 20 minus 7, which is just 13 ohms. So now we found the resistance value of the battery, the internal resistance of the battery. So R2 is just 13 ohms. That's it.